today's lecture we will solve question 8. Now in question 8 it is asked that using the orthonormality of plus k and minus k prove the commutation relation between Si, Sj is equal to I epsilon ijk h cut sk and anti-commutation relation between Si, Sj is equal to h cut by 2 delta ij, where the value of operator Sx and the form of operator Sx in this kth basis are given below. This and this. Now after solving this problem, let us see that what is the meaning of this symbol epsa ijk. Now epsa ijk is equal to 1 plus 1 if the value of ijk is one of these three value y, x, y, z or y, z, x or z, x, y. If the value of ijk is one of these three value, then this symbol gives plus 1, otherwise it is minus 1. Now let us solve the question. First, to solve the question, let us calculate the value of Sx into Sy, which is equal to h cut by 2. Value of Sx is bra plus ket minus plus bra minus ket plus times I h cut by 2 minus bra plus ket minus plus bra minus ket plus is equal to I h cut by 2 plus minus ket it will operate on the first plus minus, there is a minus sign, then again plus minus minus plus it this time this, that means minus minus plus plus then minus, this will be minus, so this is minus and then this times this, that will give minus plus minus plus, and from the orthonormality we know that this is 0, this is 1, this again is 0, this is 1, and there is another I h cut by 2 from this multiplication which I missed earlier, so is equal to I h cut by 2 into h cut by 2 plus minus state. If we see the given value of Sz, we will see that h cut by 2 plus bra plus ket minus minus ket minus bra minus ket is nothing but Sz, that means it is Sz. So it is I cut by 2 Sz. Now let us calculate what is the value of Sy, Sx. Sy This is I h cut by 2 into h cut by 2. What is the value of Sx? Minus bra plus gate minus plus bra minus gate plus. Now Sx plus bra minus gate plus minus bra plus gate. This is I h cut by 2 h cut by 2. This times this, that will give 0, since minus plus from the orthonormality we know that this will give 0. This times this will give 1, that means plus plus. Now this times this term will give 1, that means minus minus this term, since plus minus will give 0, that means only these two terms survive. Now if we take minus outside the bracket, it will minus h cut by 2 into plus bra plus gate minus bra minus gate, which is nothing but sz, that means minus I h cut by 2 sz. Similarly, that means Sx Sy is equal to Sy is minus Sy equal to I h cut by 2 sz. From this we can calculate the commutation relation between Sx and Sy. So the value of Sx comma Sy is, this is nothing but Sx Sy minus Sy Sx, which is, as we calculate previously, Sx Sy equal to I h cut by 2 sz, I h cut by 2 sz, and the value of Sy Sx equal to minus I h cut by 2. That means I h cut is sz. Since Sx that means Sx Sy is equal to I h cut epsilon x y z, if the value corresponding to I j k is x y z, that means epsilon x y z is 1 into sz. Now similarly we will get the commutation relation of S y is z is equal to I h cut Sy is z I h cut Sx and is z Sx is equal to I h cut Sy. So hence we proved the commutation relation. Now let us prove the anti-commutation relation. Is x comma is y is equal to I h cut by 2 is z, sorry, is equal to Sx Sy plus Sy Sx, which is I h cut by 2 Sz minus I h cut by 2 Sz. That means it is 0. Now let us calculate the value of Sx square, which is h cut square by 4 into bra plus ket minus ket minus bra plus ket minus ket minus bra plus. This term multiply with this term will give 0. This term multiply with this term will give 1. Only these terms survive. That means h cut square by 4, only these terms survive. That means plus. Now if we multiply this term with this term, then this term will survive. But if we multiply this term with this term, plus minus, this will not survive, it will become 0. That means this term will survive, that will be minus. And since these eigenkets follows the completeness relation, that means this is nothing but identity operator, h cut square by 4 by I. Similarly, Sy square means minus h cut square by 4 into minus bra plus minus ket plus minus bra plus ket multiplies minus plus bra minus ket minus bra plus ket. So if we multiply this term with this term, since minus plus, it will give 0. If we multiply this term with this term, minus, it will be 1. Then that means only these terms survive. Minus h cut square by 4 minus plus. Now if we multiply this term with this term, it will give 1. That means minus. If we multiply this term with this term, it will give 0. That means only these two terms will survive. Plus h cut square by 4, and this nothing but identity operator. So we see that anti-commutation relation between Sx, Sy is 0, but anti-commutation relation between Sx, Sy, Sx, what it will be? Sx, it will be 2Sx square, that will be nothing but 2 into h cut square by 4, that will be 2 h cut square by 2 h cut square 4 into identity equal to h cut square by 2 into identity. Similarly, Sy, its anti-commutation is 2 Sy square, that is also h cut square by 2 identity. Similarly, we can prove that Sy Z is equal to 0 and Sz Sx is equal to 0, but Sz square is all equal to h cut square by 2 into identity. That means anti-commutation between Si comma Sj is nothing but h cut square by 4 delta ij. If I equal to j, then delta j ij 1. That means if I equal to j equal to x, sx square, then it will be h cut square by 2 into identity operator, right? There will be identity operator. That is, so we have proved the question 8. Now we will solve question 9, which is an interesting problem. Here it is asked, construct a eigencase s dot n cap plus such that this ket is an eigencase of this operator s dot n cap. Now let us solve this, where this n cap is a unit vector in this direction. So let us see that what is the component of n cap along z direction, which is n cap cos beta. Means in this direction the component is cos beta, and the projection on the xy plane means what is the value of this? This is sin beta, and what is the projection that is on the x direction? That will be sin beta into cos alpha, sin beta into cos alpha. And what is the y direction? That will be sin beta sin alpha. That means n cap is nothing but n cap is sin beta cos alpha x cap plus sin beta sin alpha y cap plus cos beta z cap. So the dot product between s and n dot will be sx into sin beta cos alpha plus sy into sin beta sin alpha plus sz into cos beta. So this is our operator. Now let us use the matrix representation of, now let us use the bracket notation of this operator as we have seen in the previous problem 8. What is sx? What is the sx in the bracket notation? It is h cut by 2 plus minus 8 plus minus 8 plus and sy equal to I h cut by 2 minus plus ket minus plus minus ket plus sz is h cut by 2 plus plus ket minus 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 ket minus . Now operate sx on plus ket, it will give h cut by 2 plus minus minus plus on plus, it will give, this will be 1 and this will be 0, that means it will give h cut by 2 plus plus minus, only this term left, that will be give minus. Similarly if we operate s x on minus, it will give h cut by 2 plus. And if we operate on sy, operate on plus, it will give, let us check, I h cut by 2 minus kit plus bra minus plus kit minus bra plus, it will act on plus kit, it will act on plus kit, this will give 1 and this term will give 0, then that means I h cut by 2 minus. And if we operate, similarly operate on minus kit, it will give minus I h cut by 2. And we know that sz plus kit is an eigenkit of sz, corresponding eigenvalue is h cut by 2, that means it will be 2, and sz minus will be minus h cut by 2 minus. Now since these two kits are the these two kits are the base kits of the whole kit vector space, that means any vector can be written in terms of plus minus. So we can also written these eigenkits, that means is dot n cap in terms of this. Let us write a plus b, a plus b minus, and here mod a square plus mod b square is equal to 1 for normalization. Now let us operate on this state is dot n cap, operate on this state a plus b minus, it should give, since it is the eigenkits of this operator, then it will give h cut by 2 a plus of b minus. Now explicitly check what is this value. So now let us write the operator is dot n cap in terms of sx, sy, sz, which is sin beta cos alpha sx plus sin beta sin alpha sy plus cos beta sz. Now operate these on the state a plus b minus. So this will equal to, this will be sin beta cos alpha sx, operate on plus, give h cut by 2 a minus, and it operate on minus, it will give plus, that will give that. Now operate these with this, it will give sin beta sin alpha sy, operate on plus up, it will give h cut by 2 into I h cut by 2, it will give, what it will give, let us check that what it will give, it will give I h cut by 2 minus it. So that means first term will be a minus, and second term it will give minus I h cut by 2 plus, that means then it will give, and there is a I h cut by 2, and last this term apart on this is trivial, it will give cos beta a plus minus b minus h cut by 2, which is equal to h cut by 2 sine beta cos alpha a plus I sine beta sine alpha a minus b into minus plus h cut by 2 sine beta cos alpha b plus minus, sorry, here is a minus, so minus I sine beta sine alpha b minus plus a cos beta plus, and since this is the eigenkits of this operator, this should be equal to h cut by 2 a plus b minus, that means this term is equal to b and this term is equal to a, which is sine beta cos alpha b minus I sine beta sine alpha into b plus a cos beta should be equal to a, and a sine beta cos alpha plus I sine beta sine alpha minus b, there will be a sine beta, there will be a cos beta which I miss here, there is a cos beta, so here this is the b cos beta is equal to b. So now let look at the equation 1, which means this equation, so that will be, let us common b sine beta from these two terms, b sine beta cos alpha plus I minus I sine alpha plus a cos beta minus 1 is equal to 0, which is equal, which means b sine beta e to the power minus I alpha plus, what it mean, a cos beta minus 1, we know that 2 minus 2, know that minus 2 sine square beta by 2 a is equal to 0. That means, and here we know that 2 b sine beta by 2 cos beta by 2 e to the power minus I alpha minus 2a sine square beta by 2 is equal to 0. Since we know that, since it is true for all beta, that means sine beta by 2 is not equal to 0. It's only one value. So since this equation holds for any arbitrary beta, that means this is not equal to 0. That means it will be b cos beta by 2 e to the power minus I alpha is equal to a sine beta by 2. And the same relation we will get also from the equation 2. So from here we can see that this equation will be satisfied if we take a is equal to cos beta by 2 e to the power minus I alpha and b is equal to sine beta by 2. And these two also satisfy this normalization constant, that means mod a square plus mod b square, which will be cos square beta by 2 plus sine square beta by 2 is equal to 1. That means the value of a is cos beta by 2 e to the power minus I alpha and value of b will be sine beta by 2. That means the state which is eigencase of the s dot n operator, which is s dot n corresponding to the eigenvalue plus, which is a plus up, that means cos beta by 2 e to the power minus I alpha plus sine beta by 2 minus, this is the eigencase. This is the eigencase. This is the eigencase in terms of eigencase of the sz operator. These two are the eigencases of the sz operator. Then the eigencase of the operator s dot n cap will be cos beta by 2 to the power minus I alpha plus sine beta by 2 minus. So we have derived it. Thank you.